and causes
What's
it.
the hell?
SIR2, complex of proteins, attaches to the telomere.
So SIR2, do you guys remember what heterochromatin is? So there's like euchromatin and heterochromatin in a nucleus. Yeah, chromatin. And heterochromatin is the stuff that doesn't get transcribed, so it's transcriptionally inactive, whereas chromatin is transcriptionally active. And things that have SIR2 on it become
Heterochromatin.
it becomes heterochromatin.
What silences it?
So it effectively silences that region.
The transcription of chromatin is silenced by
Oh,
SIR2.
all that stuff has SIR on it.
Yeah.
And SAD, what is
Holy
SAS2?
shit, good job.
SAS2 allow. I didn't do that before. I don't know.
We didn't talk about SAS2.
It
so
promotes
I'm not
transcription.
Just fuck it all. How's that
Hold
sound?
up.
So SAS2 promotes this transcription, SIR2's like, get off my telomere, bitch.
Yeah.
SAS2.
Is that what it's like?
So SIR2 just inhibits transcription?
SIR2, yeah, it inhibits transcription. And like the way it does that is,
Oh, it increases acetylation of histones associated with that DNA.
I thought it was the histone deacetyl.
Yeah, that's what I thought so too. Oh no, loss of SIR2 causes increased acetylation.
yeah.
So SIR2 deacetylates it, and by deacetylating it, it
causes
folds
problem.
in and then can't transcribe.
Bam!
Fuck yeah!
That's deacetylation. Now, methylation is the direct opposite.
Yeah.
Okay.
So by methylating some shit,
Deacetylation.
you also fold it in.
Yeah. Deacetylation is analogous to
Methylation.
methylation.
Yeah.
Whereas in it
It
turns
always
it into
works.
heterochromatin.
Yeah, fucks itself. It's closer.
And then DNA methylation.
Wow.
That's where we had that
Are you recording?
duplex
Yeah.
and DNA.
It's gonna be good. Fucking.
This is the best video we've made.
Get off my fucking telomere.
So
Where if it sees only one
Dropping the
side,
F-bomb every 5 minutes.
Fuck.
Yep, this is great.
So we need to methylate the other side.
yeah. So you guys remember when we talked about
Get off my
DNA or DNA replication?
Yeah.
And so
The fuck is that?
it's, well, you replicate DNA.
You a fucking man, bro.
So the way that it inherits the silencing of that is
Heroin?
so if you have like this is
Wait, that's a
chromatin.
histone.
Well, this is all
That's
chromatin.
DNA, yo.
And then so these are histones.
Can you please get a picture of this white boy in his ghetto ass hat?
What?
DNA, yo.
Straight be tripping. Be straight tripping.
I'm gonna send this video to Downtown.
This
Bro,
video's
see
gonna be
how
on
old
Facebook.
last is.
What the fuck, them
wait,
curly things?
Wait, what is this?
Is that your weave?
Oh,
Pubic hair.
Shit.
After studying for till 5 from 2 to midnight.
So
This is what happens.
Family on there.
So
Won't
this
tag you.
is, DNA, and it has histones in them. The DNA is wrapped up, or well, no,
Looks like
this is
ball
chromatin.
sacks with pubic hair.
And as I was writing, they're gonna say it's ball sack. It's like, damn it. Oh well.
Yo, them ball sacks interpercolating.
And so the chromatin is, or well, the double-stranded DNA is wrapped up in histones, and these histones interact with each other through the floppy region, and the floppy domain of the histone, and the floppy domain actually gets like tagged with different residues, and depending on how they get tagged, they interact differently. And generally, what we've learned in this class is acetylation equals heterochromatin. No.
It's chromatin.
Euchromatin?
Yeah.
Good chromatin.
And then
Deacetylation.
Methylation.
equals
Hetero.
hetero.
And then you can do the non of either of the
Yeah,
other ones.
and then the opposite means
Yo, you forgot an E in hetero.
Wait, what's the opposite?
Shut the hell up. You're a hetero.
whatever.
Hetero. I
Mario Duncan can get away with it.
Patron.
Just like spell.
So acetylation is good, methylation.
Well, not
Acetylation
Depends
means
if you want it
if you
sound
want to
like
open it or close it. Acetylation opens it, methylation closes it.
Yeah.
And vice versa. Or demethylation opens it and deacetylation closes it.
Okay.
Yeah. And then so when the DNA gets replicated,
Through the floppy regions.
the histones get transferred to the new. They get like divided evenly between the two new strands. And so, for instance, say that this region right here was all acetylated, right? So when the new strand gets made, new histones localize to create more nucleosomes, and because the histones next to them are acetylated, then they will also get acetylated.
What's the recombinase that does that again?
Repeat that again, please.
I don't remember.
DNA methyltransferase.
Yeah.
But she's a fucking man.
So which part? Repeat which
The
part.
fucking man, not a fucking man.
Repeat which part.
That
What?
after it splits, okay, say it replicates.
So
Half of
replicates-
the original histones go with one, half with the
Yeah.
other. And then what happens to fill it back up?
So there's just histones floating around
in the middle of
in the
nowhere.
nucleus,
Okay, cool.
and they go to the new DNA
And fill it back up.
and fill it back up, and then they
Get acetylated or methylated accordingly.
replicate the signals that the neighbors have. So like if these are acetylated, then they'll get acetylated because
To
of the
be
ones
so,
next to
so
it.
it gets filled back up with
It
to
conserves-
whatever state the others are.
Yeah, exactly.
Well,
So then, so this is one method. So this is one method of how silencing gets inherited. There's another method of silencing where